What's up, ladies and gentlemen, to another live stream. I'm going to change things up, though, a little bit on this one. One thing I've been wanting to do is get to more of your guys' math questions, because each and every day, or not each and every day, but at least each and every live stream, I always receive so many questions. And I want to be there for you guys, even though I can't answer every single question I get. I want to make sure, though, that I can answer questions that are submitted to me. Let me make sure I put the right one. Sorry, I didn't have this ready. There we go. So if you do have any math questions that you want me to go and answer on this live stream or on one of my channels, then you can go ahead and submit it at brianmclogan.com/Q&A. Now, so what I'm going to do is I'm going to go through just a couple of math questions that students have submitted to me. And then what I'll do is I'll get to any of your guys' questions. So if you have any general questions, I also have a question as a poll for this live stream that you guys can go ahead and submit. Just want to kind of know where you guys are in the school year. My daughters started school this is going to be their third week of school. So us down in Florida, we usually start pretty early. I know I have some cousins that are in California and they do year-round schooling. So they probably started 5-6 weeks ago. And, but I'm just kind of curious because I know there's people, from all over the world that are taking. So just kind of looking when you guys have started school. So I know as you start, getting ready into it, then, the studying and everything else starts getting a little bit more important. But back where I was from, originally in Michigan, we usually didn't start till right around the Labor Day timeframe. So I know there's still a couple weeks that you guys have before you're starting school. But if you're on the stream, then welcome, because you're in the right spot to getting ready for this upcoming school year. So what I am going to do is I'm going to go ahead and transition over to getting my live stream on for the math portion. And then what I'll do is I'll just go over these three questions. Again, these were submitted to me by students. So if you're interested, I also have a pinned comment in the chat that you can go ahead and use the link right there. And then if you want some more help, there's also a lot of students that are just like you that are in the Discord server that is more than happy to, help you out. And if you can help out other people, that helps you understand math in a deeper level. So I would recommend if you're, going to the Discord, just don't go there to, ask questions. I mean, obviously you want to be able to get help. I get it. But also look for other questions that you might be able to help and solve, because that was one of the number one things that helped me get better at math was when I became a tutor at my local college, which is actually Western Michigan University. So, let me go ahead. Let's see if I got everything. Let's transfer this over. Get into my full screen. And then voila. Let's, there you go. Perfect. Okay. Sharua says, okay, so I have no idea how to do this. Could you please help? Now, I wrote sometimes the easiest solution is first because I was going to, think about making a separate video on this one. But I know the graph might be a little small for you, and I apologize for that. So I'll try to do my best to kind of describe what I can see and what we're looking at. So looks like we have either the cotangent or tangent graph. We got to be able to identify which graph this is. So I think it's important when we're looking at a problem like this to break down what is it we know about the sine and the cotangent graph. So if I can draw this, there you go. All right. Now, again, as a student that is, probably this would be like a pre-calculus question. This is something I would expect my students to be able to know. Okay. So this is going to be our tangent graph, and it's going to have asymptotes at pi halves and at negative pi halves. Okay. So I'm going to write y is equal to the tangent of x. And then we have the cotangent graph, which is y equals cotangent of x. And this one is going to have a asymptote at 0, a vertical intercept at pi halves. So I'll write that as pi halves. And then we're also going to have another vertical asymptote at pi. Now, the important thing is these are what we call the initial periods. But the important thing to recognize with tangent and cotangent, as you can see in the graph that we have here, these graphs are going to repeat, right? Infinitely to the right and infinitely to the left. What that means is for the cotangent graph, I'm going to have another x-intercept at pi, or pi more than pi halves, which is going to be at 3 pi halves. And in the same note for tangent, I'm going to have another intercept here at pi. Now, again, we could also go in the negative direction, right? So I could also say there's another x-intercept. If that's at pi halves, this would be at negative pi halves. Okay, so everything's going to be shifted again, pi, have a difference of pi distance away. Like the two asymptotes are pi apart, and you just keep on adding or subtracting pi to get to the next term. Now, again, that is without any transformations. Okay, so what we have over here is, it looks like that is at pi. So this is going to be at 3 pi halves. All right, at 3 pi halves. And then this is at 2 pi. So no, that's at pi. I'm sorry, I'm messing that up. That'd be at 3 pi over 4. Sorry about that. I know I made a mistake. That is going to be at, looks like it's at 3 pi over 4. Okay. And then this one would be 3 pi over 4 minus pi over 4. So that'd be what? 6 pi over 2? No. And then 5 pi halves, 2 pi halves. We're going at pi over 4. Pi halves, 3 pi over 4. I think we're adding to that. Why did I get my number? Why did I get this mistaken thing? 3 pi over 2 plus pi over 4. And that'd be 7 pi over 4. I don't know, I'm confusing myself. Let's go and take a look, or what I'm confusing. That'd be at a 6 pi over 4 plus a pi over 4. So that'd be 7 pi over 4. Yeah, because that's 8 pi over 4. Okay, that's right. So this would be a 7 pi over 4. And then this is 2 pi, which is the same thing as 8 pi over 4. Okay. So how the heck are we going to transfer either one of these graphs so that now we're going to have intercepts at 3 pi over 4 or a 7 pi over 4? It kind of gets like a little bit confusing. So what I would look at is kind of going back into, rather than thinking about these with the fractions, what I would do is actually kind of forget about pi for a second and just deal with some real numbers. We have to somehow say, like, can I take 1/2? What transformation would I have to take 1/2 to get it to a 3 pi over 4, right? So think about this. If I was just going to, well, actually what we could do is say, if here's going to be my intercept at here, and then if I add the 3 pi over 4, is that going to take me to a, is that going to take me over to a 3 pi over 4? Now for tangent, it would, right? If this was the tangent graph and you shifted 3 pi over 4, then you'd get that. The problem is that is not a tangent graph. And then also we need to remember what our shifts are. This is going to be taking the graph, shifting it to the left, and this is going to be to the right and to the right. All right. Now, the other thing is we can see that these are creating these tangents. These are coming with a vertical reflection. So therefore they're going to have the same orientation as our cotangent graph. So what I would look at is, let's go and take a look at, these graphs. So if I had x plus 3 pi 4, so if I took a 1/2 and I added a 3 over 4, right? So let's pretend that here is where my x-intercept is, and this is actually going to be shifting it to the left, 3 over 4. So let's go and do that. So if I was at 1/2 and I subtracted a 3 pi over 4, what I would get is a 2. Multiply, get the common denominators. Geez, oh man. Why is this taking so long? 2 pi over 4 minus a 3 pi over 4, which is going to equal a negative pi over 4. Now again, you can see at this point, if I have this pi halves, that looks like that might be that negative pi over 4. So let's go and check this negative. Let's check this other one. If we have a point at a 7 pi over 4, would that take me down to this 3 pi over 4 if I went ahead and, I'm sorry, if I took a 3 pi halves Yeah, because my second point is at 3 pi halves, and if I subtracted a 3 pi over 4. So let's take this other one, and let's go ahead and subtract a 3 pi over 4. So if I took a 3 pi over 2, no, 3 over 2, and minus a 3 pi over 2 minus a 3/4. Okay, and again, when you multiply by a 2 over 2, you're going to get a 6/4 minus a 3/4, which is equal to a 1/4. And you can see that if I, no, wait, I did that math. Yeah, that's a 3/4. My bad. There you go. That's going to take me to a 3 pi over 4. So if I have this point and I subtracted it, you can see that that looks like a negative pi over 4. But if I take a 3 pi over 4, or my second point, which would technically be a 3 halves, and if I subtracted a 3 pi over 4, that's going to take me to this 3 pi over 4 right here. Now, let's go and take a look at these other ones and kind of see why they would not make sense. And again, all we're simply going to be doing is applying this transformation. So if I took a 1/2, now again, this is 3 pi over 4 to the right. So my correct answer here is going to be A. But let's go and take a look at these other ones and kind of see what exactly is that going to be doing to these other graphs. If I took my initial asymptote of 1/2, and let's just write it as 1/2, and I added a 3/4. So again, do the math, get the common denominator. That's going to give me a 2 over 4 plus a 3 over 4. That's going to equal a 5/4. A 5/4, ladies and gentlemen, would be right there, right? And you can see that this graph is not on there. So that is not going to work. Now, this one is the exact same as that one. But again, if you think about this, if you're taking this graph, reflecting it, right? But then again, this is going to be, this is not starting at 0. This is going to be shifting it a 3 pi over 4 to the left. So if you think about the next point, which would be pi, and then if you subtract 3 pi over 4, that's going to give you a positive 3/4, right? Because again, if you think about this, you have 0, and then you have pi, right? So that's technically like 1, and then you're shifting 3 pi over 4 to the left. So 1 minus a 3 pi over 4, well, that's going to equal a 1/4. Again, a pi over 4. But again, we don't have an intercept at pi over 4. So that one's not going to work. And then this last one, this one kind of gets a little tricky because in this case, this actually has, is going to be a horizontal, let's see, a vertical, sorry, so it'd be a horizontal compression. And it looks like this graph is still going to have, so what we can do is we can rewrite this. So we have a negative tangent of 2. You have to factor out the 2, so that's going to be an x minus a 3 pi over 4. So this one looks like if you took this tangent graph, reflected it, and then shifted it 3 pi over 4 to the right, it looks like now that would actually go ahead and would actually go and work. But then again, we have this horizontal compression, which I don't believe that this really represents a horizontal compression in that case. So therefore, I would say that this one is also can be deemed not, even though the transformations look like it would match up. But that's where I would just kind of approach it. I would kind of get rid of the pi's. I would just look at the asymptote or the intercepts that we know are from cotangent and tangent, and then apply the transformations by adding and subtracting there. So hopefully that was helpful for you. All right. The next one, what are the steps to determine how to solve trig identities questions in which you have to solve in terms of sine or cosine, and sometimes there's inverses and sometimes there's not. So I know exactly what you're kind of referring to, but I actually don't know specifically what you're referring to. So it's really kind of hard to answer exactly this question, to dial in exactly that, give you some examples that's going to help out, because this student submitted these two problems, which doesn't really provide or give us any context to what I was talking about when you're solving a trigonometric equation using identities to be able to using inverse operations. I'll speak a little bit to it for those of you that are kind of curious, that usually we're going to use inverse operations when we, as long as we can get our trigonometric function isolated. Now, a lot of times when we have it isolated for a double angle or a half angle, that's a lot of times when we can use identities in that case. Or if we have more than one trigonometric function, a lot of times we'll go ahead and use our identities in that case. But we're still, a lot of times we'll be using the inverses. It really kind of depends on the context of the question and what we're trying to identify. Because a lot of times when we first learn about solving trigonometric equations, that is in chapter 5 before we get to identities. And then we enter into using identities. And rather than using the notation of providing the function or the function inverse, we use the unit circle to be able to kind of provide. So if you have some more questions on that or some specific examples, then put it down in the comments down below and I can kind of speak directly to that. But let's go and talk about this because this is what you submitted. So it's a little different than your question, but this one says, write the expression in terms of sines and cosine and then simplify it. So what we need to understand is there's a couple things. You actually sent out a lot of questions, but you only selected these two. So the main thing that I think I want students to remember when we're trying to simplify our trigonometric functions is our Pythagorean identities. And specifically, cosine squared of x plus a sine squared of x is equal to 1. Okay? And what's important about this, though, is we can create the other Pythagorean identities just from this. All we simply need to do is divide every term by cosine squared of x. And again, you could use theta too as well. You don't have to use our sine. But if we divide everything by cosine squared of x, then we're going to come up with our next trigonometric identity. Cosine squared of x divided by cosine squared of x is 1. Plus sine squared of x divided by cosine squared of x is going to be a tangent squared of x. And 1 divided by cosine squared of x is going to be a secant squared of x. Then if we do this all over again, but rather than dividing by cosine, let's go ahead and divide by sine. So let's say, let me give you a, let me get back to that pen. There you go. So there's our other identity. And then we can go and divide everything by sine squared of x. And guess what, ladies and gentlemen? Now we're going to get our other third Pythagorean identity. Cosine squared of x over a sine squared of x is going to be a cotangent squared of x. Sine squared of x divided by sine squared of x is just going to be a positive 1. And this is going to equal a cosecant. I got a little happy there. Cosecant squared of x. That's our third one. Okay. So if you look at the problem the first student sent is they say sine squared of theta times a cosecant of theta minus 1. And again, the directions of this problem are write each expression in terms of sine and cosine and simplify it. So obviously we already have a sine squared that's in terms of sine, right? That's in terms of sine. Cosecant is not. But what I do is I look at, whenever I see a trigonometric function squared, I always want you to think, or a little bell in your head, you go ding, 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 think of your Pythagorean identities. I have cosecant squared, I have cosecant of theta squared minus 1. What does that equal to? Because I have my Pythagorean identities written like this. Cotangent squared of x plus 1 equals cosecant squared of x. So what I want you to be able to understand is we can rewrite these. Like what if I subtracted a 1 on both sides? Right? Then I can rewrite this identity as cotangent squared of x equals a cosecant squared. Why do I keep messing that up? A cosecant squared of x minus 1. Look at this. Cosecant squared of x minus 1 is what we have right here. So now I know that cosecant squared of theta minus 1 is equivalent to a cotangent squared of theta. I know I'm mixing up the theta and the x. It doesn't really matter what your input variable is. I could have all replaced x's with thetas. Sorry, that's just what I originally wrote. So to go over to question number 11, what I would do is if I had a sine squared of theta, and then it's times cosecant of theta minus 1, I can rewrite cosecant squared of theta as cotangent squared of theta. So I have a sine squared of theta times a cotangent squared of theta. Now, again, it's still not written in terms of sines and cosines. So how can I rewrite, what is the relationship with cotangent and sines and cosines. Well, ladies and gentlemen, we did it right here, right? Cosine over sine is equal to cotangent squared. I'm sorry, cotangent squared over sine squared is equal to cotangent squared. So what I can do now is I can rewrite this as a sine squared of theta times a cosine squared of theta all over a sine squared of theta. And just remember, the sine is represented as over 1. So now, by applying the division property, those are going to divide out. And now I'm going to be left with a cosine squared of theta. And that is going to be the simplified version over there. Let's go and take a look at this next one. In this next example, I have a 1 minus sine squared of theta divided by a 1 plus a cotangent squared of theta. Okay, so again, we know that I can rearrange them like I did over here to get what I want. Now, in this case, you can see I actually already have what I want. Cotangent squared of x plus 1, that's the same thing as 1 plus cotangent squared of x, right? So we're good there. Now, what about this as far as my Pythagorean identities? In this case, I have cosine squared. Let's go and rewrite it up here so you can see my transformations. Here I have cosine squared of x plus a sine squared of x is equal to 1. But in this problem, I have a 1 minus sine squared of theta. Well, what happens if I subtract my sine squared on both sides? What is that going to give me? Now, again, I'm using x's, I know, and the problem has thetas. It's okay, though. Just make sure that when you're working on your problem, you're using your thetas. So if I subtract a sine on both sides, I'm going to have a cosine squared of x is equal to a 1 minus a sine squared of x. Ladies and gentlemen, that's exactly what I want. So now I can rewrite this problem as cosine as 1 minus a sine squared of theta. I can just rewrite that as cosine squared of theta. And in my denominator, I can rewrite that as 1 plus cotangent of x. I have the same thing. That's going to be a cosecant squared of x, or sorry, of theta. We're dealing with thetas, right? Okay. So again, we got to write it in terms of cosine and sines. So what is cosecant? Now you could think about that as, again, where did we come up on this one? We came up from it as a 1 over sine, right? So what I'm going to do is I'm going to rewrite this as a cosine squared of theta divided by a 1 over a sine squared of theta. Now we have a trigonometric function divided by a fraction. Ladies and gentlemen, we don't want a fractions in the denominator. So how do you get rid of our fraction? Well, you get rid of a fraction by multiplying by something that the denominator evenly divides into. Or you could think about this. How do you get rid of a fraction? Yeah, you can have your denominator divide into it. Or if you think about it, if your numerator is divided by 1, you no longer have a fraction, right? If I have like 8 over 1, I can just rewrite that as 8. So how can I get my fraction to be 1? Multiply by its reciprocal. So what is the reciprocal of 1 over sine squared of theta? It's going to be a sine squared of theta over 1, right? Which we call the reciprocal. Now remember, to produce what we call an equivalent fraction, I have whatever I do in my denominator, I have to multiply in my numerator. So I'm going to multiply my numerator by sine squared of theta over 1. Do I really need to rewrite it over 1? No, I don't, right? But we know that those are going to divide out using the division property. And I'm going to be left with a final answer of cosine squared of theta times a sine squared of theta. Now, if you want more practice, the student actually provided a lot of examples. So I would recommend going back through those examples. But hopefully my description, at least working with converting to sines and cosines, which is a very, very helpful and important task for you, was answered. Now, ladies and gentlemen, for those of you that are on this, if you want me to get to your questions, then feel free to add them down in the chat. If you have actually a math problem, you want me to go over a math problem for you live on this live stream, then go to brianmclogan.com/Q&A. I am going to do one more math problem that was submitted by a student, and I will do one more math problem that was submitted by a student, and then I'll get to your guys' questions. So feel free to add them down into the chat because I will be looking at that chat right when I am done, making sure there's nothing else that we have there. Okay, cool. All right. Elvin says, tips on how to pass pre-calc, for example, algebra of functions. F plus of x, f minus x, fg, f of x. Okay, so let me go and tackle this in two different ways. I will talk about how to pass pre-calculus, and then I'll talk a little bit about the algebra of functions. Now, this is actually something that is more, I would say, focus on algebra 2. It is a lot of times, it is in pre-calculus, so it is something I would cover, but I wouldn't say it would be like the most important thing for you to make sure that you know how to do. Like if you like still were like completely confused on this, obviously for your future math projection, I'd want to make sure you have like some understanding here. So I'll give you some tips on it, but I don't think it's the most important thing for you to know for passing pre-calculus. But let me give you some tips on practicing pre-calculus, being a pre-calculus teacher for over 10 years. I think the number one thing is to understand, do more than what your teacher is expecting you to do, right? Because at least for me, when I was teaching pre-calculus, I would have students that were barely, qualified to be in the pre-calculus. Like they still had a rough foundation of the math. And even though they might've gotten like A's in algebra 2 and geometry and algebra 1, they didn't truly really understand what they had done. And pre-calculus is going to be a struggle with them for the whole year because they had to go through a lot of that stuff that they didn't understand. This was me when I was in high school as well. I was not prepared to take pre-calculus. But then there's also students that are like pre-calculus is kind of like they're just being forced into it. They could probably even go right into like calculus. Like they're just ready, right? Math really kind of comes easy to them. And they're those students that, could probably teach the course almost to themselves. So, obviously as a teacher, we have to cater to as many students as we can, but it's also a very difficult job. And I would always provide a baseline that I would expect all my students to be able to complete, like on homework and, classwork. And then obviously there would be some more foundational stuff that I would provide for the students that struggled, and then some more challenges for the students that were doing all right. But again, I had a baseline. And I think for a lot of students that feel like if they're not prepared for pre-calculus or if they want to get an A, you need to understand, you need to go above and beyond. Don't just expect whatever your teacher provides you, that if you just do that, that's going to give you an A. I always told my students, if you do everything that I tell you to do and you work hard and you ask questions, you are not going to fail this class. Like I will do whatever I can and is possible for me, staying after school, helping you out, whatever I need to help you make sure you get credit for this class. But notice, I'm saying credit and not passing, right? The only students that passed my class were the ones that gave up and they stopped trying and they didn't care. Those were the students that would, fail or get D's in my class. And when I failed pre-calculus, that's exactly was me. Or I got a D in pre-calculus. I just didn't care. I kind of like gave up. But if you put in the work and you do what I ask you to do and you do my assignments, I am going to make sure that I have done everything I possibly can to make sure you pass the class. I'm going to give you multiple opportunities to assist you. Okay. But if you want to get an A is not for everybody, and not everybody needs or deserves to get an A. So I don't want you to feel like that needs to be a carrot on your stick of like, you have to get an A, because I had those students where, they felt like if they didn't get an A in my class, their life was over. I get it. And I understand where they're coming from, but I don't want you to hold that above your head. I want you to go above and beyond what you feel is expected from your teacher. And just because your teacher is giving out some homework, do some more extra problems. Just because your student gave a study guide, find another study guide and do it, right? Do more than what is expected, especially if you are a student that math does not come easy to, and you kind of feel a little bit overwhelmed in pre-calculus. Number 2, this is a big one. Understand why. When I was in high school and I got something wrong, I was just like some of my students. I would just, throw it away in the trash can and be like, whatever, like I'll just worry about the next test. Like hopefully this stuff's not going to come up again. And that was really bad. Because what I want you to be able to do, if you want to be successful in a course, you need to be able to face the reality of when you fail, of when you don't understand something. And sometimes we're going to have teachers that are not very encouraging to go up to and ask questions. I hoped for my students as a teacher that I was not a representation of that I was always very welcoming, because I always wanted them, hey, if you failed this test or you got these problems wrong, it is your responsibility to make sure you understand why. And one of the things that would make me the most angry as a teacher is, when I would see students that, I'd be up to like 11 o'clock at night with my, newborn, crying and feeding them. And I'm grading papers right before the day of school. And I pass them back to the kids, and the kids would just crumple up. They didn't get the grade they wanted, crumple up and throw it away. And I'm like, I can't help you. in that regard. But when you get a B or a C or a D and you just completely bomb it, and you have to come up to me and we have to have the conversation of what it is you got wrong, why it is you got wrong, and make sure you understand that, ladies and gentlemen, that stuff sticks with you. You're more likely to not make those mistakes again if you can understand what it is we did. And ladies and gentlemen, you're going to make mistakes. Sometimes they're going to be what we call like dumb mistakes. Like, you know what you're doing. You had a mix up in your brain while you're taking it. And there's going to be other times you're like, I just don't understand this concept. So you're going to have to spend a little bit more time understanding it. But I was always willing to help and work with students and coach them when they were coachable, when they wanted to get better, when they wanted to understand why they got things wrong. So, if you want to get that A, I think you got to have that mindset of, I'm going to do more work than is required. I'm going to put in the extra work. And I'm always going to make sure that I'm trying to understand what it is I need to know. Okay. Because you can game the system, guys. I know every teacher, after even myself included, students would learn how they could get a better grade on, how they can improve their grade, like make sure they're doing their homework and blah, blah, blah. And they always tried to game my system. Right. And sometimes they did. Like, I remember there were sometimes I was giving out grades and students got a good grade. And I was like, man, how did that student get that A? And I'm like, my grading policy maybe might be messed up because that student does not have an understanding of A, but they figured it out. And I was like, you know what? I can't blame anybody else but myself. Like, that's how I created the grading system, for that particular semester. It is what it is. Congratulations to them. But I know a lot of times they were doing shortcuts, right? They weren't doing the advice that I just gave to you. And I was like, you know what? Eventually it's going to hit them. So congratulations to them. They beat my system, but I know eventually they're going to, get caught. Not like they were cheating caught, but eventually they're going to be exposed for the information that they don't know. All right. So let me give you just a quick little tips, again, on operations of functions, because you did ask about it. I think the main thing that a lot of times students will get confused with operations of functions is going to be the notation. So just remember, if I have like f plus g of x, all that simply means, ladies and gentlemen, is f of x plus g of x, right? When you have that fg of x, that just means it's going to be a f of x times a g of x. And then the most famous one, when you have f of g of x, or f fog, and golf, I think was the other one I used to refer to it. Just remember that just means f of g of x. Okay, so that's going to be what we regard as our composition. So a lot of times when you see this, just make sure you understand it from on there. Now, when you're applying multiplication, subtraction, addition, division, it's really just kind of comes into whatever function you're dealing with. Now, again, in Algebra 2, when we teach this, we probably deal with some fairly basic ones like linear, quadratics, maybe some cubics, but we kind of stay with focused on basic functions. What I think the next thing that usually gets students confused is the variety of the functions that we deal with in pre-calculus. So just remember, you can only apply operations with like terms, right? You can only add an x to another 3x, right? It has to have the same base and power. And that's going to work for all of them, right? So just make sure you understand how to do those common like terms, as well as going to do the operations with each of the functions. And the third thing that usually students will have trouble with is going to be the domain. So remember, if we have domain restrictions, like you can't divide by 0, or you can't take the square root of a negative number. And obviously we have other ones like, x has to be greater than 1 or greater than 0 for a logarithmic function. Remember those domain restrictions. And remember, when we're applying operations, it's the and, right? It has to be true for both of the functions. So when you're writing out that final domain, make sure you're including both of those. And then the last one, the one that kind of gets the most attention when we're talking about domain, is going to be when we're doing composition of functions. So again, that is going to be a and, but you also need to make sure that you include, even though it has to be included with the with your original function. So, what your input function is. So that is going to be, you got to make sure that you include the domain the domain of that input function, okay, as well as then what the final composition is going to be. So make sure you go ahead and include whatever the input function is for on that. So hopefully that was helpful for how to pass pre-calculus, as well as a quick little review on function operations. All right. There you go, ladies and gentlemen. You know what? That felt a lot better. I'm not going to lie, on just doing some math right off the bat, because one thing I always hated having is when I would do these live streams and I'd get your guys' questions, because that's what I really love doing more than doing math questions. I just love answering your guys' questions. I love being there and answering the questions for you. But the thing that would stink is I'd be like, all right, now I'm going to go ahead and do some math questions. And then I've already been talking for like an hour or like 30 minutes or 45 minutes. It doesn't really matter. And just my brain gets tired and I can't really explain or do the math very, very well. And it just kind of gets old. So I apologize for that, but hopefully that was a little beneficial for you. And again, if you have some math questions, go ahead and submit them at brianmclogan.com/Q&A, and I'll be happy to do my help. And then otherwise, now I'm just going to get to you guys' chats that I can get to. And then and we'll be good for a good Sunday afternoon. All right. Hey, Spicy Tomato. Good to have you on. I need help with factoring polynomials. Please help. I have a test on Monday. Well, you are in luck. Please go ahead and submit at brianmclogan.com/Q&A. Let me know if you do submit that. And therefore, I'll see if I can help you out real quick. Thank you, Wycar. I appreciate that. You're saying, hello, how are you? Ooh, we got a thing. All right. Finished my first Algebra 2 honors semester last night with a 90%. All thanks to you. Well, not all thanks to me, but I appreciate that. Thank you much. But you put in the work, so good for you. Applying to a different school this fall. Feeling very confident thanks to your videos. Thank you. You got it. I mean, I love that I can be there as a fail-safe for students to give you that confidence. And I think that's really important, because when you have that confidence, you know that you're going to have some support that you can understand from somebody. And in this case, it'd be me. I really feel honored for that. But yeah, you got your whole world and challenges ahead of you. So, keep on challenging yourself, keep on pushing yourself. And you're right. You got this. All right. I get really confused when solving derivatives that have trig in the exponent and using natural logs. Can we do one? I'll give you an example. Sorry, it's been so long since I taught calculus. Whatever my explanation would just be very rusty. So usually one of my goals was to get back into doing some of my calculus stuff. But unfortunately, it's been over 3-4 years now since I taught calculus. So I would have to go back over and review. And then even then, my explanation would be pretty rusty. So sorry about that. I just am not able to do the calculus questions yet. I'm about to go to Calculus 3. Do you have any tips? I heard it's really hard, and I've also heard it was easy. So I never had to take Calculus 3, even though I have a math degree. I had to do the Calculus series up to Calc 2, and then I went into a whole bunch of other, math topics. But I feel like really, as long as you have the fundamentals of doing a lot of the, calculus work, then you are prepared enough to handle in the Calc 3. And you're right. I've heard a lot of the same regards. Everybody, I think, is going to have a different experience, but I would just focus on, the fundamentals of what you've done in Calc 1, what you've done in Calc 2. Make sure you review a lot of it, go back through a lot of those practice problems. And I would just, I think the more practice that you do, the more confident you're going to be as you start getting into the Calc 3 material. But from what I've heard and from what I know, there's nothing crazy new that you're going to experience in the Calc 3, right? It's going to be an expansion of what you've been doing. So just make sure you have that strong foundation and you're going to be fine. I do. And a lot of times I do read the live chat. So yes, give me those polynomial problems and I'll see what I can do. Ms. McLogan, I don't have any questions, but I wanted to tell you thank you for all you've given to us students. Your blessing. Well, thank you very much. I appreciate that. Bro, 100%. I do. Hey, Fire Bashers, thank you so much. Can you explain vertical and horizontal compression in Algebra 2? All right, let's see what we can do here. Is there any more questions? Yeah, that was it. All right. So are done session. Give me that polynomial. Let me know if you got it in there. Let's go and do a horizontal and vertical compression. What can I do for that? All right. Does linear equations on graph, is it in 8th grade? I don't know. I never taught 7th and 8th grade math, but I would say probably, yeah, like in a pre-algebra course, that would probably be about right. All right. Can you explain vertical and horizontal compression on a graph? Yes, there's a couple things that I can talk about on vertical versus horizontal compression. Let's make sure. Oops. There we go. So let's talk about vertical and horizontal compression. Okay. Oh, I'll say it again. So let's go and talk about vertical horizontal compression. Again, if you have any other questions, put them down in the chat. This will probably be my last math question that I go to. So for vertical and horizontal compression, I think the main thing that I want students to understand is the difference between vertical and horizontal transformations. So if I have a function, f of x, come on. All right. Now there's a couple different ways that I can transform this graph. I can multiply on the outside, and then I can multiply on the inside. And then I can add or subtract on the inside. I'll write this as an x minus c. Oops, sorry. X minus c. Or I can also add or subtract on the outside. Okay, so let's see, one more, plus d. Now again, this might be a little confusing for some of you, so I'll go ahead and do some real numbers for you. Don't worry about that. The main thing that I want you to understand is between A, B, C, and D, there are some similarities and some differences. A and B are multiplying and dividing. Those are going to be your horizontal, those are going to be your stretching and compressions, as well as your reflections if they are negative. Your C and D are being added and subtracted, right? So those are going to be your translations, your shifting, right? Left, right, or up and down. But the more importantly thing that I like to really dive in with my students is notice where A and D are. These are what we call outside operations. Do you recognize that they're outside of the parentheses, right? They're outside of the f of x. So these are called outside. Now, when we're dealing with outside transformations, those are going to be what we call vertical transformations. So that's why we say when A is negative, it reflects the graph about the x-axis because that's a vertical transformation. When A is larger than 1, that's a vertical stretch. When A is between 0 and 1, that's going to be a vertical compression. D is your vertical shift up or right. Then let's go and take a look in here. See how these are inside of our f of x? These are what we call our inside operations. Now we're dealing with inside operations. Those are going to be horizontal. So again, that's why if B is negative, that's a reflection about your y-axis, which is a horizontal reflection. If B is larger than 1, instead of being a horizontal stretch, that's actually being a horizontal compression. And if C is going to be your horizontal, and if B is between 0 and 1, that'd be a horizontal stretch. And then we can also look at the C is going to be a shifting left or right. But again, notice the operation is x minus c, right? So a lot of times I even like to put this around in parentheses because it's the opposite, right? If you have like plus 5, that's a shift up 5 units for D. But if it's plus 5 inside the function, that's actually shifting 5 units to the left because it's x minus c, okay? So couple little notations in there, even though I know you didn't ask that. So let's go and take a look at a function to kind of break down and understand these transformations. So in this case, I have f of x equals the square root of x. Now there's a couple points that I want you to know for this graph. And I'm just going to do a couple. So what if I had, let's do x and then f of x. So I know if I did 0, square root of 0 is going to be a 0. If I did 1, square root of 1 is 1. If I did 4, So if I plug x in for 4, square root of 4 is going to be a 2. So 1, 2, 3, 4, I got 2. And then obviously I'm just going to do one more, which would be 9. Square root of 9 is going to be 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. Okay. So the square root graph looks like that. Voila. Okay. All right. So now what I want to be able to do is, oh, I'm sorry, square root of 9 is 3. Okay, so that is going to be our parent function. Now let's go and look at some transformations of what would happen if I had some different points in here to go ahead and to work with, right? So what about if I had the square root of 2x? Let me do a different color. Okay, so f of x equals 2 square root of x. Now again, we don't have to pick any of one of these. Let's just pick 4 though, because that's going to make an even number. So we know 0 is going to work, but 1 would be a little bit different. Let's go to 4. So we know it's going to go over here, and we know it's going to take on that shape. But if I plug in 4, square root of 4 is 2. 2 times 2 is going to be a 4. So 1, 2, 3, 4. Instead of at 2, it's going to be 4. So do you see how that is going to be vertically stretching the graph? And then let's do one more here. Let's do yellow. Actually, I'll do another one. I'll do these both as green. So again, what if I did f of x is equal to a 1/2 square root of x? Well, now if I plugged in 4, square root of 4 is going to be 2, right? 2 times 1/2 is going to be 1. So 1, 2, 3, 4, it's going to look like this. So you can see how that's like a vertical compression. So that is going to be 1/2 of x, and this would be a 2 square root of x. All right. So now let's do some transformations inside to see how that kind of compares. Now that's where it gets a little bit difficult in this case, but we can still work on some numbers. So what if I had f of x equals a square root of 2x? Now again, I want to work with some numbers that are going to work. I don't have 2 in here, but I'm going to have to use 2 in this case. So what if I did f of x equals 2, or x equals 2? 2 times 2 is equal to 4. Square root of 4 is 2. So at 2, 1, 2, I'm going to be at 2. So you can see the vertical compression is not as much as the vertical stretch, but it is not the same, right? The vertical compression is not the same as the vertical stretch. It's a little different because I have the point here at 2, 2. When I plug in 2, I get 2 on the out. And so that's going to be the square root of 2x. And then let's go and do a horizontal stretch. So if I had f of x is equal to square root of 1/2 x. So in this case, I'll use 4 because if I plug in 4, I can multiply that 1/2. Now we know on the original graph, 4 is 2. But if I plug in 4, actually, I'm not going to use 4. Dang it, that's not going to work. Well, I'll also get square root of 2, which I don't know what the square root of 2 is, but I guess let's approximate. 8, 16, 25, 50. I'm not getting anything that would even work. What do I do? I want to use a different number. What if I did, I don't want to use 9. What do I got to think? Oh, let's use 8. There we go. So if I plugged in 8, I don't have 8 in here because that doesn't work on the original function, but I plugged in 8. 8 times 1/2 is going to be 4. Square root of 4 is 2. So let's go to 8. So 1, 2, 3, 4, 5, 6, 7, 8, and then I'm at 2. So what you can see here is again that it's the vertical or the horizontal stretch is not the same as the original function, right? But it's not as much as the horizontal compression. So the horizontal stretch is different than the vertical compression. So therefore, this is going to be a 1/2 of an x. So hopefully that helps you out. That gives you a little bit of understanding for on there. All right. Now, ladies and gentlemen, if me going over some math was helpful for you, then please feel free to go to brianmclogan.com/Q&A, and I will do my best to go over the questions for you guys, just like I did in this live stream. So one of the things I like to do is go live every single Sunday to answer and help you guys out with those questions. If you have a general question that you'd like me to go into, then feel free to put it down in the chat below. But I don't know. I cannot confirm every single time I'll be able to. Ari. I will not be able to confirm every single time. I have completed the form. Sorry, didn't mean to be rude when I said bro doesn't read chats. Well, Ari, thank you so much for submitting that. But I don't have every single time, but I will go live on Sunday, but I'll try to do my best to give you guys some advance notice. It all really depends on what my kids are doing and what plans we have. All right, since Ari, I did say I will go to your stuff, or I'll answer your question. I'll see if I can get my form open for you and see if I can answer your question, because you did call me out. I believe Ari, right? That's what you said? That's your name? Confirm if that's good. Where is it? Open live Q&A. There you go. All right. Let's see. He said, hi, McLogan. I'm starting Calc 2 this semester. Do you have any advice, tips for doing well in the class? It's kind of funny. I answered one just a little bit earlier on the stream of how to do well in Calculus 3. And my advice to you in Calc 1 or for Calc 2 would be the exact same for Calc 3. Like, make sure you have a foundation of what you've done before. Like, go back over, practice some of those problems. Make sure they're second nature, because I think that's so important when you're getting to the calculus series or even pre-calculus. Even in Calc 1, there's an expectation going up to that level that you know how to do this stuff that you previously did, right? You don't want to go up to your teacher in Calc 2 and be like, I have no idea how to take the derivative or integrate. So you might have a general idea, right? But if you don't have that stuff practiced and it doesn't feel natural to you, then do extra practice. So my advice to you would be make sure that you go back through what you learned in Calc 1 so you have a firm understanding of it. Because yeah, Calc 2 is going to be an expansion of what you learned on Calc 1. So there's going to be an expectation of things for you to know and to make sure you understand, not that you just got a good grade. Okay. So hopefully that makes sense. All right. Got it. Let's see. Okay. I think the issue for me really is manipulating the algebra of logarithms. Maybe we could do an example where we solve a logarithm, like say 3 log base minus 6. Well, that's not an equation, so I'm not sure what you want me to do on that. But if you want to submit it to brianmclogan.com, then I'll be happy to help. Hey, Ren, I'm doing very well. Question is Muscle just came here to say, thank you for helping me talk. Well, awesome. So happy to help you out. Hi, Ms. Morgan. Could you review sequences and series? You know what? Sequence series is kind of like one of those things that also like calculus, even though I just need to go back and review the content, review my instruction. Any explanation I'm going to give you is going to be rusty. I haven't taught sequences and series or gone over any problems or needed to in probably like over 5 years. So one of the things I do want to go back over to do some review for that kind of things, but hopefully I'll be able to get that to you. But yeah, as doing just a like kind of ad lib review, it's just not something I've done in a while. So I don't want to even try to give you a rusty explanation for that. Go ahead and submit it at brianmclogan.com/Q&A and I'll help you out. Hi. I don't know what your doubt is, but maybe. Can I get yours up? There you go. How much harder is pre-calculus than AP stats? So I think there's a lot of things that can depend on it. There's a couple things that pre-calculus, unless you're taking AP pre-calculus, is not an AP course, right? Immediately, if you're just comparing AP pre-calculus and a standard pre-calculus, you got one, AP stats has the AP component of it. AP is a different animal. That's going to require a lot from our students as far as studying and as far as preparation. However, from students that were in my school, at least for me, when I was teaching pre-calculus, they said your class was much more difficult than stats. They much more preferred, or at least were happy when they were done with my class and they got to stats. Now, a lot of that can be attributed to the differences in stats compared to a pre-calculus course, and then also the teachers and how we're going through. Like I knew the stats teacher. Great friend of mine. But we also, are going to have different teaching styles and everything else. So, sometimes you might just be, connect better with one teacher or the other. But then in the other realm, even though students would say my course in pre-calculus was more difficult than their stats, it also prepared them for calculus. And that was my overall goal, was to, challenge my students. So therefore they're prepared for the next course. And pre-calculus is not really a gateway for AP stats. Like, I don't think, obviously, there was some foundational stuff, like my school advised that students take pre-calculus so they kind of get ready and prepared for an AP course before they go into AP stats, but it was not required. And some students would bypass pre-calculus and do perfectly fine in AP stats. So I think in a general sense, there's going to be some more difficulty with an AP course if it's AP stats or AP pre-calculus. But they're completely different animals. So depending on how you approach math and your knowledge of math, if one is going to be harder for you or the other, that's going to be really dependent on where you stand. All right. Ari, thank you for providing that. Let me see initially if I can get to your question, what we got here. Ari, which one do you want me to do? You sent me 4. You said I'm skipping your comments. I just but I didn't see which question you want me to do. Yeah, sometimes. I mean, we do cover a lot of stuff in Algebra 2 from pre-calculus. I think actually in the beginning of this live stream, I answered a student's question, and it was kind of like, it kind of puts pre-calculus in perspective. Because yes, in pre-calculus, we do cover a lot of the same content in Algebra 2, but then also we do cover like new stuff, like a lot more trig and getting to that and conic sections and, for so on and so forth. And there's a lot of stuff that we don't we just cover directly verbatim from Algebra 2, but then especially on functions. So we were talking about transformations of functions. And I said hey, in Algebra 2, you're probably going to do transformation of functions, but it's going to consist of some basic functions, maybe quadratics, linear, and that's really about it. But once you get into pre-calculus, then the hard thing that I think a lot of students have with pre-calculus is I'll teach the operations of functions and the composition, everything like that. And I'll go over a couple examples. I'll do 3 examples, but I can't cover every single type of example. And then they're going to see on their homework and on their quizzes, on their tests, sines, logs, exponential, square roots, cubics, absolute value. They're going to have all the stuff that I didn't have enough time to cover because I can't possibly cover every single type of problem. So it's a lot of Algebra 2 stuff, but then it just expands on stuff. And there's not enough time for a teacher to literally go through every single type of example. So rather than it's me teach and then you do, it's kind of hey, I'm going to teach. And then now you have to apply to all these different scenarios. And that's what a lot of students have trouble with in pre-calculus. I took AP Statistics 2 of 3 semesters last year. Junior year, got B's in both trimesters until I dropped the third semester. I feel like I should take it again. Yeah, I think so. I mean, if you feel like you need it, then if that's what you're going through and you want to put in the work, then yeah, go for it. What is the unit circle? I started learning about in trigonometry. I have so many videos on the unit circle. I would just recommend going through them there. I actually have a course on learning the unit circle. It's free. It's on YouTube. So if you just look into Let's Learn the Unit Circle, you can go and check that out. It's on my YouTube channel. All right. Let's go and see which one you want me to do. I don't know. I want to make sure. This one looks pretty messy. I'll do 24. Hopefully, I would do 25, but I'm not sure what Z exactly is. so I can't tell. But I think I can do this one. What am I looking at? Okay. All right. Come on. Sorry, I just got to add this in there. Okay. All right, well, good. Well, then I guess I won't do 24. 23. I mean, I don't know. Is that a Z? I don't know. Maybe you can tell me. Is that Z to the 10th power? I mean, it looks like a good problem. I just can't. Or is it Z to the 0 for number 25? But that's why I wanted to do one where it has the power to the product. I'll do 25 and I'll just make it up. But confirm to me, hopefully, in the next like 1 minute, if that's Z to the 10th, which I think it is. So I'll look out for your comments. All right, but Ari sent me this one to go ahead and simplify using the rules of exponents. So let's go ahead and see. Oh, well, sorry, I forgot to turn my screen back on. All right, Ari sent me this question to go ahead and simplify using the rules of exponents. I realize it might be a little bit of fuzzy, so I'll try to do my best to clean this one up. So what I am reading is a x to the negative second, y to the negative first, z to the negative second, times a y x squared, z to the 10th, I don't know, 0, cubed, divided by a negative 2, I don't know, I guess I'm going to have to wait for your pick, because, yeah, I'm going to need something better than that. Just make sure it's nice and clean. All right, I'll wait for your next pick. Maybe I'll, oh, come on. Why you do this to me? All right, I got to wrap up this live stream. All right, so I am going to probably get into, I'll do this one. I'll do 23. Go ahead and submit your question. Go ahead and submit that better pick. And I'll try to do it next live stream, even though I'm sorry that might not help you initially. Sorry, but I gotta wrap up. Okay. All right, Ari sent me this question to go ahead and simplify. So it looks like from what I can see, I know it's a little bit blurry, but it looks like I have a negative 3m to the 4th, n to the negative 2nd, p cubed, times a negative m to the negative 4th, n to the 4th, p to the negative 1, all divided by, and again, that negative is out in front, a 4m squared p cubed. Whew. Okay, so a couple things that I like to do, okay? Now, a couple things that I would say to approach this. If I had 3 times 2 times negative 1, right? It doesn't really matter. I know when I multiply this out, that's the exact same as a negative 3 times 2 times 1, right? I know this product is going to be negative, right? So if I have a negative, what I'm going to do is I'm just going to throw that all the way to the in the front. Now, again, the other thing I want you to recognize is if I had like a negative, I don't know, 3/2, that's the same thing as a negative 3 over 2, which is the same thing as a 3 over a negative 2, right? The negative can go on the top and the bottom. So the first initial thing that I see with this problem is I have 2 negatives, right? I have a negative that's being represented in front, and then I have a negative in here. So if I take that negative all the way to the front and I move this negative up, I can rewrite this problem as a negative, and then times a 3m to the fourth. Now, what I'm also going to do is I'm going to get rid of all of my negatives, okay? So my negative powers. So if I have anything that's a negative power up here, I'm just going to go ahead and make it positive. Yes, you can apply the product rule of exponents when they're up here, but I'm just telling you a lot of students will make mistakes with negatives, so I'm just going to go make them positive. So I'm going to put I'm not going to worry about the n. That's going to be a p cubed. This is now, and then I have an n to the fourth. All right. And then down below, this n to the negative second power, that's going to be a n squared. M to the negative fourth, that's going to now be an m to the fourth. And then I have a p to the positive first power. And then also I have this times a 4 m squared p cubed. Okay. So all I did is I just rewrote, I got those negative coefficients. I wrote all the negatives out in front, put them in one, either numerator or denominator, or you could put them in top and bottom, doesn't matter. But what we recognize here is that these are going to go to a positive, right? And now the next thing I'm going to want to do is I'm going to want to put that 4 in there. But now if I have any like terms in my numerator and denominator, I'm going to want to do that. So up here in the numerator, I don't have any like terms. So I'm going to rewrite this as a 3m to the fourth, p cubed, n to the fourth. But my denominator here, I do have some common terms. So I'm going to write the 4, put that out in front. But you can see here, I have my m's and my p's. Now just remember the rules of exponents. If I have a to the n times a to the m, I can rewrite that as a to the m plus n, right? So technically these are being multiplied by each other. I'll just do one more step just in case, okay? You can rewrite them next to each other if you really want to, because what that will do is help you understand and help you see that, oh yeah, these are being multiplied by each other. So p to the first p cubed. You don't have to do this step. You can kind of skip it and show what the step I did over here. But a lot of times if you're like, don't want to make mistakes, or if you just need a little bit of help understanding things, rewriting them next to each other is kind of really helpful. So here, that's supposed to be correct. Did I forget to do that? No, yeah. So I have an n squared. And now I'm multiplying these. So that means I'm adding the power. So that's going to be an m to the sixth power. And then here I'm adding these two. So that's going to be a p to the fourth. Okay. Now what I want to do is rearrange them. So vertically, they are going to be exactly the same. I could have done that on the onset, but I kind of made the mistake. So sorry. Wasn't thinking ahead. So I have a 4. So that's my m. That's an m to the sixth. And this would be a p to the fourth. And this would be an n squared. Okay. So just like we had over here, when you multiply, you add the powers. So when you divide a to the n divided by a to the m, you are going to subtract a to the n minus an m. Okay. Now again, just remember, if I have a to the negative n, that is going to now be in my denominator. Okay. So if you have a negative power, then it's going to be represented in the denominator. And again, the rule of exponents, which you could have done, which I did. No, there's no negative in the denominator. But again, just to finish off the rules of exponents, if I have a to the negative n, I can rewrite that in the numerator as a positive. Okay. So in this case, I'm going to have a m to the 4 minus 6, which is equal to an m to the negative second. So I'm going to want to put that in the denominator. P is 3 minus 4, which is going to equal p to the negative first power. That goes in the denominator. And then n is going to be a, n fourth divided by n squared is going to be a 4 minus a 2, which is going to be an n squared. So that's going to stay in the numerator. So therefore, my final answer is a 3/4, and then we have a n squared, and denominator is going to be a positive m squared, because I'm going to put that in denominator to make it positive, times a p to the first power, but I'll just leave that as a p right there. All right, ladies and gentlemen, I have to go ahead and run. Thank you so much for joining me on this live stream. I hope this live stream was helpful for you. And I hope your going back to school has been a success thus far. And if you haven't gone back to school, well, just get ready. You're going to do great. But you know that I will always be here to answer your questions every single Sunday, answer your questions, help you guys out. Thanks again for hopping in, and I look forward to seeing you guys next week. Cheers.